Looking on YouTube and on Facebook. You're very welcome. I'm Mrs. Altafourie and I'm going to represent some tips for you for Technical Science Paper 1 that you are writing on Friday. Excuse me, let me just get there. Now, general hints, by now you have planned your study time. So it's always good to plan your timetable and to sit with it. But when you plan 7 hours sleep so that you are rested and your brain is rested, I suggest that you study difficult work when your mind is fresh. For example, in the morning, but sometimes people are better at night when it's quiet. Take a 10-minute break every 50 minutes to exercise or to eat or to walk the dog, something like that. Now, when you study, what I would suggest to you is that you have two main things with you. And that is that you have your textbook and other books that you might have, but the main thing that's important is your exam guideline. You need to do studies from your exam guideline for the definitions, no textbook definition, exam guideline definitions. Then I have some general pointers when you answer 150 marks. So if you take a minute for a mark, then you have 30 minutes remaining of a paper. Now how you do that is you take the question, you look at the total marks, and then you say, for example, first question is 20 marks, you take 20 minutes for that. And then you go on. Don't stay long on questions that you struggle with. Rather move on and come back later to it. Start with the topic that you know the best with, but keep the sequence of the question paper. In other words, question 1, question 2. You can leave pages open. Your book is numbered also. Each topic have definitions. You must memorize them from the exam guideline. Make sure you understand the meaning or the law of a principle because we find that many mistakes come in because learners do not know what is the correct symbol for something. Here, identify or highlight what you think is important. Make notes in the diagram if there is one. Collect your data from the question. Then you choose an appropriate formula. That's why you need to know the symbols for the different things. And then you use the formula from the information sheet. It's very important that you do not manipulate the formula, but write it down exactly as it is. Do not leave out subscripts like FNet. Do not before you manipulate and then calculate the final answer. The final answer is normally 1 mark if it has a correct unit with it. Unit is not a unit. You must have, for example, Newton for force. Make sure you know the units. If there's a vector of a force, then they ask just a scalar unit. You don't have to give direction then. And then remember to round off the final answer to a minimum of 2 decimal places. When you get to multiple choice questions, learners lose a lot of marks because you go over them too fast. You have to work on these questions because they're testing knowledge like that's a question. Use it. I suggest that you cover the answers with a ruler and try to answer the question before looking at the option. Then focus on the other possibilities. Choose only one because there is only one. Don't leave this question unanswered. So make a choice there. Even if you write the answer in a pencil first and come back to it later, don't leave it open. You might just be right. And then here is also important, when you get to your questions, I would suggest that you take out the information sheets, the formulas with you. When we break down the topics of paper 1, it has 3 main topics: mechanics, electricity and magnetism, wave, sound and light. Mechanics is the heaviest count. Of the 150 marks, 93. Electricity and magnetism around is the general direction that it must be. Then 30% for questions where you have to write down, choose a correct formula, where you have to analyze the question. 40 is 5%. If we get to the topics in mechanics, then elasticity, viscosity and hydraulics, 21. If we get to the electricity and magnetism, is electrostatics, electric circuits and electromagnetism, in total about 33 marks. For wave, sound and light, about 24 marks. And unfortunately, learners do not do well here because you don't study this, and this is really easy study work. If you study this topic, you should be doing well, and this should be good marks. But we have seen that the last topics that I mentioned, the learners, which is about more than half of the paper, Learners do not do elasticity, viscosity, and hydraulics. Now, marks are lost because learners do not know the names of the symbols of this topic, and they use the inappropriate formulae. If you have a wrong formula, you can get millimeters to meters, also from square millimeters to square meters, that you can get this units right and know what it means. If they say kilo, it's 1,000th of. Ne? If they say milli, it's 1,000th, divide by 1,000. Or micro, divide by 1,000,000. Or if it's mega, it's 1,000,000 of. Make sure you know how to convert. Because if you can do the problem, but you do substitute wrong values in, you get a mark only for the formula. Then learners also do not give the correct SI unit at the answer. I'm going to talk to you about how to calculate area. If it's a circle, the diameter squared over 4 will give you the same answer. If it's a rectangle, then it's the product of the length and the width of the rectangle. So symbol is area is length times breadth. And remember, your answer for area is square meters. So if they give you values in millimeters, you need to convert it to meters before you can do the calculation. Now, if we get to elasticity and plasticity, the definitions here are fairly okay answered, but you confuse this then when we get to inelastic and elastic collision, so make sure you know which definition is where. Elasticity is where a body regains its original shape and size after the removal of a deforming force. Plasticity is where you have a permanent deformation after the force that has been deforming, after the removal of the deforming force. Then a unit area. In symbols, it is sigma is F over A. Now that sigma looks like an O with a formula. Learners confuse the formulas for stress and strain. So this one is the force over the area. And the unit is Pascal or Newton per square meter. That is the stress. When we get to the strain of the material, it's the ratio of the change in dimension of an object to the original dimension. And this means an object can get longer or it can be compressed. So two directions. The formula looks like a funny E, but it is epsilon, is the change in length over length. Make very sure that you see whether you get the change in length already. Sometimes learners get a change of length and then they want to subtract it again from the original length. So make sure you know that. So it's delta L over big L. Is the big L is the length of the original material. Now, because you are dividing millimeters with millimeters or meters with meters, this strain has no unit. It cancels out. With compression strain, the length decreases. Now, the further part is Hooke's law and the modulus of elasticity. Now, in Hooke's law, we say that within the elastic limit, stress is directly proportional to strain. That means sigma for stress is directly proportional to epsilon for strain. And that gives us a constant value. The constant value is called Young's modulus. So you use the symbol K for it, and K is a measurement of the resistance of a material to elastic deformation under a given load. For example, if you take your ruler and you bend it, you know it will spring back. So it has resistance to the elastic deformation. But when it breaks, it has exceeded the stress and strain. Okay. The higher the value for K, the stiffer the material. So if the material will change its shape only slightly under elastic loads, the lower the value for K, the more flexible the material is. And like your ruler, if you overstretch it, it will break. So it has a higher K value. Now I'm going to discuss an example. So have your pencil ready that you can maybe write down the example, that you can see how to calculate it. Example says, we have a 15-meter marble column with a cross-sectional area of 3 square meters. And it supports a mass of 15,000 kilograms. The column measures 14.7 meters after the load is applied. Calculate the stress within the column. Now, so in other words, it was 15 meters long. It is now 14.7. So this is a compression force that is applied onto it. To calculate the stress then, it's the formula for stress, sigma equals to F over A. And the force is the weight of the body. So you have to calculate the weight using mass times gravitational acceleration. It's 15,000 times 9.8, which will give us 147,000 Newton. So if you substitute the value into the formula, it's 147,000 over 3 square meters, and it gives us 49,000 Newton per meter squared, or 49,000 Pascal. You can also write this in scientific notation, in other words, 4.9 times 10 to the power of 4 Pascal. For the second question, we ask you, what is the strain on the column? If the marble column is decreasing in length now calculate the strain. So the strains, epsilon, equals to delta L over the length. And the change in length is that 15 millimeters minus the 14 will give us 0.02. No unit, because the meters will cancel the meters in this example. 5 millimeter in diameter and 2 meters long. Remember, diameter is a cross section, so a radius will be a half of 2.5 millimeters. They apply a force of 12 Newton to it, and it causes it to stretch 0.3 millimeters. Assume that the material is elastic and calculate the stress within the wire. So first need to calculate the area of the wire. The area is pi radius squared. So it's 2.5 times 10 to the power minus 3, because it was millimeters. To convert to meters, you need to divide by 1,000. Divided by 2, and that is squared. So the answer for that works out 4.9 times 10 to the power of minus 6 square meters. Now you substitute the area then in the form of minus 6, gives us 2.44 times 10 to the power of positive 6 Newton per square meter, and that is the same as Pascal. You can also say 2.44 megapascal. Now for the second example, they ask you now, if a force of, it's for stress and strain, and then they get no marks. And people, this is easy work. So make sure that you know which is stress and which is strain, and that you know the symbols of this work. So the correct formula is epsilon is change in length over the original length. You may also convert the 2 meters to millimeters, because the unit will cancel out. It is allowed. And then you will get 1.5 times 10. Look into this and get your formula definitions right. Going on to the topic of viscosity. The viscosity of a fluid is a property of a fluid to oppose a relative motion between two adjacent layers. In other words, it's how easy material will flow, like motor oil. Now, the viscosity of a fluid, of liquid, will decrease with an increase in temperature. So, intermolecular forces weaken with an increase in temperature or friction to decrease. Now, when we heat syrup, for example, it flows much easier out of a bottle, while in the winter, it's difficult to squeeze out syrup from a bottle. Viscosity of liquids decrease with an increasing temperature, while that of gases increases with an increase of temperature. Just to ask you to define viscosity, or to explain how this to the intermolecular forces with an increase in temperature. And then a question like, refer to the intermolecular forces and viscosity and explain why syrup is more sticky in winter. And then your answer will be something like this. Colder temperatures of winter decreases the kinetic energy. So the viscosity of the syrup increases, and the syrup will not flow as well as in summer. Now going to motor oils and temperature. Thin oils have a lower viscosity and pour more easily at low temperatures than thicker oils that have a higher viscosity. Obviously, thin oils will reduce friction in engines and help engines start quickly during cold weather. Thick oils are better for maintaining film strength and oil pressure at high temperatures and loads. A number like 10W50, for example, the first number refers to the temperature at which the oil is the temperature of the viscosity rate at 0 degrees Celsius. And then the other number, the last number, is the viscosity at 100 degrees Celsius. Keep in mind that motor oil companies add normally a best kept secret. Every company has their own rates, and what all the additives that they add is a highly kept secret. The functions of oil is that it must be able to lubricate moving parts. It has to cool down moving parts. It must remove high temperature deposits, clean the sludge is the way that we say. It must seal the pistons in the cylinders so that there is no leakage. That is what that means. Then we go on to hydraulics, and hydraulics is always nice questions asked. Hydraulics is the study of the mechanical properties of liquids. And here we talk of the force as the thrust. A thrust is a force, and so pressure is the force, the thrust acting per unit area. And the formula for pressure we use everywhere else. This is now thrust, this force, but it is also still used. Now here you have to be very careful, because when you calculate pressure, you cannot use the formula to calculate stress, which is also force over area. Sigma equals to F over area. That is an inappropriate formula. Do not use it here with it. And the area, the unit is still also Pascal. Now when we get to liquids and we look at the pressure in liquids, we see that we have a formula that we use. P equals to a symbol that looks like. So pressure increases with an increase in depth of liquids. So symbol pressure in Pascal, and then rho, which looks like a funny P. G is the gravitational acceleration in meter per second, and H is the depth in liquid in meters. So you don't use area for this calculation when you work with the pressure in liquids. So important, don't use stresses formula for pressure in hydraulics. Now, there are other units of pressure which I will give you enough information to if you need to be able to calculate or convert to another unit that other countries using. Kilopascal is 1,000 Pascal. 1 bar is 1 times 10 to the power of 5 Pascal, or 100 kilopascal. Normally when you pump the tires at the garage, you will say 1 or 2 bar or 1.8 bar. That refers to bar. Then there's a torr, T-O-R-R, which is 133 Pascal, or 1,01 times 10 to the power of 5 Pascal. Now to calculate pressure at a point, the definition for pressure at a particular point is the thrust acting on a unit area around that point. That is the definition that you have in your exam guideline, and that is what you must define when we ask you to define a pressure at a point. Also use the symbol F over A for that, and the correct SI unit in Pascal or Newton per square meter. Square meters, what pressure does it exert? Now keep in mind that they will not always give you the area in square meters, and that you need to be awake and convert it to the correct square meters. So pressure then thrust over area, it's 5,000 over then 5, and that gives us 10,000 Pascal. Very straightforward, this one. And next example, the density of the ocean, 1,03 times 10 to the power of 3 kilogram per cubic meter. Pure water's density, small p, I see I have a high capital P there, small p is rho times G times H, so that's the density times gravitational Pascal. Now if there is a diagram, then use that, if it helps you to choose the correct formula. Then if we go to Pascal's law, we've been finding, because it's a difficult law, it's interesting to see that learners normally know this law well, but make sure that you are one of that learners. In a continuous liquid at equilibrium, The pressure applied at a point is transmitted equally to other poles over a small area, and it will then exert a big force over a bigger area. At the other side, like this car lift, for those of you that can see it. Now this question is very popular. There will always be a similar question where you have 1 over area 1 or force 1 over force 2 equals to area 1 over area 2. In the exam guideline, they give you the formula force 1 over area 1 equals to force 2 over area 2. Use the formula like it is on the exam guideline. Do not change it or manipulate it. And then it's also important to know that the first force is smaller than other examples where it's used is in dentist chairs, hydraulic lifts. It helps to assist with car braking. Look at the different options. Here is an example for calculation. Assume that on a hydraulic press, a 220 Newton force is applied to a small piston. So this is area force 1 and area 1. The surface of the small piston is 0.12 square meters. If the surface area of the large piston is 3 square meters, what is the total force exerted on the larger piston? To force 2 over area 2. So 220 over 0.12 equals to F2 over 3. And then you can cross multiply and get your answer. Force 2, 550 Newton, where you have a force originally of 220 Newton. So the force is much bigger then. Important, this is a topic that is also, it's not difficult. It's learning work. It is a topic where you can get good marks. If sound and light is the definition for refraction, know what the critical angle is, total internal reflection, dispersion, normal, what is the incident ray, what is the angle of incidence, what is the refractive index. Now the first one that I'm talking to about you more is a reflection. Now if you stand in front of the mirror, you see yourself. That is on a lake or a dam, you see sometimes the surrounding reflected in the water. Now reflection is a change in direction of a wave upon striking an interface between two materials. And to give you an example, if you have a plane mirror and there's an incident ray on the normal at an angle, then you get that the reflected ray has the same angle as the incident angle. And that is part of the laws of reflection, because sometimes it's refract, it's reflect. The incident ray and the reflected ray and the normal is in the same plane also. Going to refraction, now in the diagram I have a picture here of a person holding a prism, and you can see the refraction of the image of his fingers in the prism. There's also a man standing on a bank in his spear fishing him. So for him the fish looks higher and shallower than it is. They know that they must throw in front of where they're seeing the image. So refraction is the bending of light when it passes from one medium to another. It also means that the speed of light can change. It can either speed up or it can slow down when refraction occurs. Right, then talking about total internal reflection. The light reflects into the original medium, which is a very useful property to use. It's used in many instances. It's used in optical cables, optical fiber, to transmit sound as light over long distances. That's why if we talk nowadays to somebody in America, it sounds like the person is here in South Africa. In the past, it took much longer for the sound to travel. The ray is smaller than is coming inflect at an angle that's smaller than the critical angle. Then you see two refracted, a refracted ray and a reflected ray. So some rays reflect in the medium backwards, and some will refract. Critical angle, we find that the refracted ray is on the surface of the medium. And when the moment the incident angle is at a larger angle than the critical angle, we get total internal reflection. So the whole ray keeps staying reflection from a denser medium to a less dense medium. For example, like water to air, or from inside glass to air, that will have total internal reflection. Study the definition also. When the angle of incidence is greater than the critical angle, the ray colors. This definition was asked in previous question papers and not answered very well. Learners will stop with the breaking of white light or the breaking of light. Instead of saying white light, and instead of saying into component colors, they will say something like different colors. But remember, it's the colors that it. We get red, orange, yellow, green, blue, indigo, and violet. An acronym to remember it, ROIC-BIF. You will remember the sequence then there. For the lenses, school. So just dig deep, but then refresh now that you can do that. A lens is a transparent material like a glass, having two opposite surfaces. They are more wider at the middle than at the edges, and concave lenses which is diverging. With them you always get that the image is formed at the same side as the object of this. Now, when you study this lens also, because you can be expected to, what is the nature of the image? And then where is it? Your focal point is 2 centimeters from the lens optical center. Then you immediately make that, then that will be F1. Then you construct the object center, and then your line must go through F2. And the other line, the second line, you draw through the upside down or right side up, and you can then describe it. Please practice it beyond 2F, at 2F, between 2F and F. See the different object where you get it. For all of the ones between F and 2F, beyond 2F it's enlarged, it's bigger than the same size. On F you get no image because your rays reflect parallel, they never intersect or intersect. Between F and the lens you get a virtual upright camera, or your eye works like that. If it's on to F, it's like a photocopier making the same size copy as the object. Lens, a diverging lens, it's hollow in the middles. Here you can place the object at any position, and the image will form on the same side of the lens, and it will be upright, and it's not a real image. Scopes. You must be able to give at least 1 or 2 applications for the lenses. With electromagnetic radiation, our next topic, learners struggle with the calculations here, so I'm going to give more attention to an electric field mutually perpendicular to each other and the direction of the propagation of the wave. So it's 3-dimensional. That's transmitted in space while vibrating alternatively. It's self-inducing. It doesn't need a medium to cause it to be transmitted. Now, the spectrum of the electromagnetic spectrum, please study the sequence as well as the functions of the different kinds of waves in the electromagnetic spectrum. And then you also must know that all kinds of radiation travel with the same speed, which is this. That's why we don't use V for the speed, but we say C for the speed. If I look at from the longest wavelengths to the shortest wavelengths, then ultraviolet, X-rays and gamma rays. That is now with from the longest wavelengths to the shorter wavelengths. Please, and remember that wavelength and frequency are inversely proportional. If the wavelength is long, so if I ask you now I give you a scramble of the names of the electromagnetic radiation spectrum, and I ask you to arrange them in order of increasing frequency, then you will write it like radio waves, microwaves, infrared. We use the symbol lambda for wavelength, and it's in meters. Frequency is in hertz. Then you have to turn your sequence around. Sorry, I interrupted myself. Of that part, the visible light is a very tiny part of it. just quickly to talk about the functions of the different kind of radiation, which is sometimes asked in questions. Radio waves have the longest wavelengths in microwave ovens and radar and satellite transmissions. Our cell phone towers is also microwave towers. Infrared radiation fires, night vision equipment use infrared also. Going to visible light, it's not possible to see if light, the visible part of the spectrum was not there. We need light to see. So for our vision, for photography, also in optical fibers, and there is the acronym that and the longest wavelengths is at the blue side of the spectrum. And there, Roygbiv, R-O-Y-G-B-I-V, is an acronym to remember the sequence of the colors. Ultraviolet light is used in fluorescent lamps. It can be absorbed by the skin, so it can. And also some animals have ultraviolet. Other animals, the way that they see it. Security coding of money, also used there. Now, X-rays, you know, most of you know, it's to take images to detect. It is dangerous in a big amount because it can also cause cancer. So people try to evade using too much X-rays. They will radiographers that work with it will carry a monitor that will detect if the radiation exposure has been. But we have gamma rays that is used in chemistry. In hospitals, it's used to sterilize medical equipment. In certain cases, sterilizes food. Also can, especially with milk, ultraviolet can also be used. All right, now the photons have different amounts of energy. We calculate the energy of a photon of light with the formula energy of light is the frequency multiplied with the wavelength. C is F lambda. We can also use the formula to calculate energy with HC over lambda. So if they give you the wavelength and they want you to calculate the energy of a specific. For us, name the 7 regions of the electromagnetic spectrum in order of increasing frequency. That's a question that they will ask. So that will be radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Question 2. Rays, because if that has the highest frequency and because the energy is calculated with constant, Planck's constant multiplied with the frequency, wavelength, it is the radio waves. Okay, then I think I went too far. Yeah, questions. The wavelength of the waves and the energy of a photon of this energy. Now to calculate the period, you must remember the period is inversely proportional to the frequency. So it gives us the frequency, but it's in megahertz. You need to convert it to hertz. So period give us an answer of 1 times 10 to the power minus 8 seconds, scientific notation. To calculate the wavelength now, we can use the formula C is F lambda. Don't manipulate the formula. My calculation here is manipulated, but then you can get the wavelength. Last question asked the energy of a photon is HF. So we have the energy, Planck's constant, 6,63 times 10 to the power minus 33 times 10 to the power of 8 meters per second, seconds, gives us. Going on to our next topic, electricity and magnetism. For electrostatics here is the first part. Now these questions are badly answered because learners confuse the symbols and they choose the wrong formulas. You must know the definitions of capacitors, examples of capacitors in technology, the capacitor in electrical charge. And capacitance is a capital C, is the amount of charge it can store per volt. So make sure what have they asked you? Did they ask you to define capacitor? Or did they ask you to define capacitance? And the symbol for unit for capacitance is the farad, capital F. Example here. A parallel capacitor has a potential difference of 100 volt between the plates. Each plate carries a charge of 1 times 10 to the power of minus 5 coulomb. Calculate the capacitance of the capacitor. So you have the potential difference, you have the charge, you must calculate capacitance. You will use the formula C is Q over V to calculate that one. I'm going a little bit faster due to time constraints. And then they ask in a second example is, during a manufacturing of a parallel plate capacitor, two metal plates, each with an area of 5 times 10 to the power of minus 3 square meters, are placed at a distance of 0.1 millimeters from each other in a vacuum. Calculate the capacitance of the parallel plate capacitor. Please remember to convert the distance to meters, cubic meters. So 0.1 times 10 to the power of, excuse, it is meters, I'm confusing myself. And you only use the area once, no matter that both plates have the same area, you only use it once, a unit in farad. Going to electrical circuits, definitions that's very important here is the definitions for potential difference. Out of that we get the potential difference across the ends of a conductor is the work done per unit electrical charge. So our formula V is W over Q can help you to remember this definition. Terminal potential difference is the voltage across the terminals of a battery when the charges are flowing in the circuit. EMF is the work done per unit electric charge by the source. It's equal to the potential difference when the terminals of a battery are open and there's no charge flowing in the circuit. Current is the rate of flow of charge. Definition, and then resistance, the opposition to the flow of electric current. Ohm's law, very important. I think most of you know that by now. Now, when we get to the definition of power, power is the rate at which electrical energy is converted in an electric circuit. We can also ask you to define the definition of power in work, energy and power, which is mechanics. It does not have the same definition. So here you will forfeit marks if you give that definition of it correct. There are different formulas to calculate power, and also the heat produced by an electrical circuit. Sure, you can handle those. For example, if I ask you to calculate electric power for a toaster that is a 120 volt power source and 6 ampere of a current, then your formula P is V times I. So the power is the potential difference multiplied with the current. You get 660 joule. What is often asked and what you must know how to use here is to calculate electricity cost. So for example, if a TV set is labeled 120 volt, which will be America, not South Africa, 2 ampere is connected to a household power supply. How will the cost of the user, much will it cost the user if the electricity company charges 20 cents per kilowatt hour and the user watches TV for 8 hours per day for 30 days? So you first calculate the power. P is V times I is 120 times 2 is 240 volt. Then convert it to kilowatt, divide it by 1,000, so it's 0.24 kilowatt, because we only pay for kilowatt hours. Ne? Multiply it with the hours used. It is 8 hours for 30 days, gives us 240 hours. And multiply the kilowatt with the hours, it's 0.24. Multiply with 240 gives us then 57.6 kilowatt hours. Then you can multiply it with the cost of 20 cents will be 2. So final cost 11 rand 52 cents. Cost, in other words, is the number of kilowatt hours used multiplied with the cost will be your formula. Our time is going fast. Just quickly, when we have power in parallel and series circuits, the more it's in series, your smaller resistor uses the smallest power. So it's reversed here. Just look at these relationships again. Then for electromagnetism, please look at your definitions for electromagnetism. Very important. One or both is always asked. And then the magnetic effect, how we determine the direction of the magnetic current, we use the right-hand rule. So if it's a single conductor, you will point your thumb in the direction of the current, then your curled finger shows the direction of the magnetic field. If a symbol is used where there's a dot in the middle, it means the current is coming out of the page towards you. And if there's a cross, it means it's going into the page. Know that conversion also, or that symbol to write it. When it's a solenoid, you still use your right hand, but now your curled fingers show the direction of the current from positive to negative. Your thumb will point into the direction of the induced north pole that is induced. Then we have transformers. We have step-up transformers and step-down transformer, which decreases the voltage. Step-up transformer increases the voltage. And you have the formula, the volt of the primary over the volt of the secondary is equal to the number of windings in the primary over the number of windings in the secondary. Use the correct formula given there also. Then a generator and a motor. A generator is a device that converts mechanical energy into electrical energy. A motor is a device that converts electrical energy into mechanical energy. You must know the symbols. You must know what is a split ring commutator and a slip ring. You know their function and know the difference between the particles. So study that. Slip rings causes the current to alternate. Now we need to wind up. So I'm just going to quickly refer to some relationships of some places where you have to look at the mechanics. There's two principles that is given where you don't get the formula. You must derive the formula from the principle. The one is the principle of conservation of linear momentum, which says that the total linear momentum in an isolated system remains constant in magnitude and direction. In symbols, we say the sum of the momentum before is equal to the sum of the momentum after. And here we use the capital sigma. Sigma P before is sigma P after. Please be careful that you don't use energy here. It's momentum, m times v, not half mv squared. Write the correct symbol for that part. And then also when you get to elastic and inelastic collisions, an elastic collision, momentum and the total kinetic energy are conserved. In inelastic, the total momentum is conserved, but the total kinetic energy is not conserved. Do not use elasticity and plasticity to define elastic and inelastic collision. Many learners lost marks that way. Then, for this one, for the momentum, conservation of momentum, the formula is not given. You must derive it. So that formula of sigma P before equals to sigma P after is one that you must derive from the formula. Also say it in connection with applications of airbags, in connection with impulse. And please remember, impulse is F net delta T. F net times the change in time is impulse. And that is equal to the change in momentum can be used to calculate the impulse of it. I am now not going to talk longer about the mechanical energy. I just want to talk to you about the conservation of mechanical energy where we have an isolated system. Again here, the formula is not given. You must derive it where you say that the mechanical energy, sum of the mechanical energy initial is equal to the sum of the mechanical energy final. This is also a definition for you to derive. Then in conclusion, I want to say that we have a competition for MTN, sponsored competition, where you can win an MTN bucket hat and a t-shirt. I'm going to ask you a question and you can send your answer to the Free State Department of Education's Facebook page to enter in this competition. You will be informed if you are the winner of this competition. Now the question for this is, write down the symbols used for impulse. I will repeat it. Write down the symbols used for impulse. And you can send that answer in. As students, I want to wish you the best for this examination. Be calm. Try your best, read properly. Make sure you read and interpret the question correctly. Also, when you prepare for Monday's paper, use your time well this weekend to study your topics. All of the best and good day.